All right, ladies and gentlemen, this is Mr. Weideman, Functions in Trig, Lafayette High School, and these were our warm-up slash review problems that we went over in class today. And we went over some of these. We're going to go over the rest of them here. Just going to do a real quick recap. All right, for problems number 1, 2, 3, and 4. These were just conversions. And you use this guy right here over and over again. And it goes from degrees to radians. It goes from radians to degrees. If I want degrees, for given degrees, put it in here, convert to radians. If I'm given radians, put it in here, convert to degrees, okay? And cross multiply, I don't know, do what you want, reduce your fractions, and this should be easy points. Okay, this coterminal angle thing, okay, everything, almost all, anything with a denominator of 3, anything with a denominator of 4, anything with a denominator of 6 is on your unit circle, and it's just a matter of counting. Or, I could take 11 pi over 3, and I could keep on subtracting 2 pi till I got something between 0 and 2 pi. That works also, but you have this unit circle, right in front of us. Let's just count. And when I count, I go 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Every time I go around, it's 6/3, 7, 8, 9, 10, 11. Boom, I'm right there. And that's what this little spiral is all about. I had to go around the circle, I had to go around it all the way once. Okay, that was 6 pi over 3, and not quite, if I went around it all the way again, it would have been 12 pi over 3, so not quite around twice. Okay, so there is my coterminal angle, that is that, and this are coterminal. This is my reference angle that I'm going to do trig on. Okay, so let's look at number 6. What do we do now? We're just counting in quarter pies backwards. Okay, so I started here and I went in this direction. 1/4, 2/4, 3/4. Oops, wrong. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, every time I go around, it's 8 quarters or 2 pi. So I go around again, that's 16 quarters, 17 quarters, 18 quarters, 19 quarters. And that's how I got this little spinny around line here, meaning it is coterminal with 5 pi over 4. My reference angle then is pi over 4. Okay? Same deal here, except in degrees. This is actually increments of 30 degrees or pi over 6s. So when I went all the way around the circle, that's 360 degrees, and then I have to go 150 degrees more to get to this point. That's where the 150 coterminal came from. That is going to be a reference of angle to 30 degrees in quadrant 2. And that's going to be super duper important for when we get to all of the later problems. Okay, this should be pretty much on autopilot. I have to solve for this side adjacent. We can just do that with Pythagorean. A little bit about calculating here, a little bit of work, and then I find out that that's square root 11, and then it is just SOHCAHTOA, and sine, cosine, and tangent, and notice how we just flip those numbers to get the cosecant, and tangent. Okay, sort of the same idea on this problem right here, except it's giving me an ordered pair. Okay, well, I know the ordered pair. This is just going to be a triangle, side adjacent of 3, side opposite of 2 in fourth quadrant. So this is really no different than problem number 8, just different numbers, different quadrant. Still have to use Pythagorean, in this case, to find out the hypotenuse. And once you know all 6 sides, then this becomes really, really easy, as long as you remember SOHCAHTOA. And then once you remember SOHCAHTOA, you can take each one of these guys and flip them. Number 10. Okay, if I'm not mistaken, number 10. This is even easier, because on this triangle, they tell you it's on a unit circle. So that means the hypotenuse is 1. All right, so the x-coordinate, adjacent over hypotenuse, so I'm just dividing by 1. So cosine of theta is going to be negative 3/5, and the sine of theta is going to be negative 4/5. I can flip these guys to get my secant and cosecant. I can divide the y-coordinate divided by the x-coordinate to get my tangent, and then I can do just the opposite, y-coordinate divided by x-coordinate by y-coordinate to get the cotangent. And I didn't simplify those fractions, but you guys can do that. Yeah, so 3 different problems, variations on the exact same thing. Okay, let's see what else we're doing now. Okay, a lot of questions on this. All right, let's see what we're given. The first thing we have to do is we have to figure out what quadrant theta is in. Well, I'm in a quadrant where the tangent angle is going to be negative, and the cosine of the angle is going to be negative. And I end up doing the exact same thing on problem number 12. I'm going to have to do the exact same thing, so I just copied that over. All right, so let's move forward here. Okay, so the tangent is negative in quadrant 2, and the cosine is negative in quadrant 2. Quadrant 2 is going to be the only place where those two things are going to occur. All right, so when I do that, this tells me that they told me that the triangle had a side opposite over adjacent. There's my opposite, there's my adjacent. I had to draw this reference angle in quadrant 2. Pythagorean gave me my hypotenuse. I have a triangle, know all 3 sides, so sine, cosine, and tangent, that's just SOHCAHTOA. And let's just go ahead and finish filling out these guys. And that's how I get those answers right there. Okay, let's do number 12. Cosine is positive. Sine is negative. That cosine tells me the side adjacent is 3. The hypotenuse is 7. It's just a matter of drawing that triangle in quadrant 4. That's the only place where the cosine is going to be positive and the sine is going to be negative. I have to do a little bit of back calculating with the Pythagorean theorem to get that side opposite. Again, I know all three sides of a triangle. Now it's just SOHCAHTOA, and then flip those guys to get my cosecant, secant, and cotangent. And that is how we get all of those answers. All right. And this video is getting pretty darn long, so I'm going to stop it here, and then I'm going to pick up on the next video.